Why Mars? Why not Venus, with its thick atmosphere, or Europa, with its subsurface ocean? The answer lies in a delicate balance of challenges and opportunities. Mars presents a unique combination of factors that make it both a tantalizing and a daunting target for exploration. Mars is relatively close to Earth, at least in astronomical terms. Moreover, Mars exhibits tantalizing evidence of a watery past. Dried-up riverbeds, ancient lake basins, and the presence of water ice at its poles all point to a time when liquid water flowed freely on its surface. As we grapple with the challenges of climate change and resource depletion here on Earth, Mars represents a potential backup plan for humanity. However, reaching Mars is no walk in the park. The vast distances involved, the unforgiving nature of space travel, and the complexities of landing on and surviving on another planet all pose significant obstacles. The journey to Mars is a long and perilous one. Overcoming these challenges will require not only technological innovation, but also a deep understanding of human resilience and adaptability. Imagine embarking on a journey so long it makes a cross-country road trip seem like a casual stroll. The average distance between Earth and Mars is about 140 million miles, a gulf so vast it boggles the mind. Spacecraft travel much faster than cars, but even at speeds exceeding 20,000 miles per hour, a one-way trip to Mars still takes around 7 months. And it's not just the duration of the journey that poses a challenge. It's also the constant exposure to the hazards of deep space. Adding another layer of complexity to this already daunting endeavor is the fact that we can't just launch a mission to Mars whenever we please. Earth and Mars are constantly in motion, following elliptical orbits around the Sun at different speeds. To optimize the journey and minimize fuel consumption, mission planners rely on what are known as launch windows. Launch windows to Mars occur approximately every 26 months when the two planets are in a configuration that minimizes the energy required to reach the red planet. Imagine being confined to your house for months, with limited space, recycled air, and the constant hum of machinery as your only companions. Comment if you would live through all that. The human body, finely tuned for life on Earth, doesn't fare well in the weightlessness of space. Bones lose density, muscles atrophy, and the cardiovascular system weakens. Overcoming these challenges will require innovative solutions, not just for maintaining physical health, but also for fostering psychological well-being. Picture this. After months of hurtling through the void, a spacecraft carrying the hopes and dreams of humanity approaches its destination, Mars. But the journey is far from over. Unlike Earth, with its thick atmosphere that acts as a natural break for incoming objects, Mars presents a unique challenge with its thin, wispy shroud of gases. The Martian atmosphere, about 100 times thinner than Earth's, provides minimal drag to slow down a spacecraft entering at high speed. Section 2. 7 Minutes of Terror. The Entry, Descent, and Landing Challenge. During this brief but critical window, a spacecraft must go from hurtling through space at thousands of miles per hour to a gentle touchdown on the Martian surface, all while autonomously executing a complex sequence of maneuvers. As the spacecraft plunges deeper into the atmosphere, it deploys a supersonic parachute to further slow its descent. In the final stage of the descent, the spacecraft must jettison its heat shield and parachute, and rely on its own propulsion system to execute a soft landing. Section 3. A Legacy of Triumph and Failure. Learning from past missions. Landing on Mars is so difficult that it's often described as trying to thread a cosmic needle. NASA has had more success with its series of Mars rovers, including Sojourner, Spirit, Opportunity, and Curiosity, which have explored the Martian surface, gathering valuable data and capturing stunning images. Each failure, while disappointing, has provided valuable data and insights that have informed the design and execution of subsequent missions, pushing the boundaries of our technological capabilities. Section 1. The Invisible Enemy. Radiation and the Human Body. Space, for all its breathtaking beauty, harbors an invisible enemy, a silent threat that permeates the void: radiation. This radiation, capable of penetrating spacecraft hulls and human tissue alike, poses one of the most significant challenges to long-duration spaceflight. particularly for a multi-year mission to Mars. Shielding spacecraft against this invisible enemy is a daunting task, and scientists and engineers are exploring innovative solutions to deflect or absorb radiation. But a foolproof method remains elusive. From the moment we're born, gravity shapes our every move, dictates our physical form, and governs the intricate workings of our bodies. It's such a fundamental force in our lives that we rarely even notice it, until it's gone. In the weightlessness of space, our bodies, finely tuned for life on Earth, begin to adapt, sometimes in ways that are detrimental to our health. Imagine floating effortlessly, unburdened by the weight of your own body. It sounds exhilarating, liberating even. And indeed, astronauts often describe the initial euphoria of weightlessness. But this newfound freedom comes at a price. Without the constant pull of gravity, our bones lose density, our muscles atrophy, and our cardiovascular system weakens. Astronauts on the International Space Station, who typically spend 6 months in orbit, experience these physiological changes to a certain extent. But a mission to Mars, lasting 2 to 3 years, would expose astronauts to microgravity for much longer periods. This prolonged exposure could lead to more severe and potentially irreversible health effects, increasing the risk of fractures, muscle weakness, and cardiovascular problems upon their return to Earth. Counteracting the debilitating effects of microgravity is a major focus of space medicine research. Scientists are exploring a range of countermeasures, including rigorous exercise regimens, artificial gravity systems, and nutritional interventions, to maintain astronaut health during long-duration spaceflight. The goal is to find the right combination of strategies to keep astronauts strong and healthy, not just for the journey to Mars, but also for their eventual return to Earth's gravitational embrace. Space travel is often depicted as a grand adventure, a thrilling exploration of the cosmos. And while it is undoubtedly all of those things, it is also a profound test of human resilience, particularly for the mind. The psychological challenges of a multi-year mission to Mars, confined within a cramped spacecraft, millions of miles from home, are as daunting as the technical hurdles. Imagine being confined to your house for months on end, with the same people, the same routine, the same 4 walls day in and day out. Now, imagine that your house is hurtling through the void, the vast emptiness of space stretching out in every direction. The only sounds the hum of machinery and the voices of your crewmates. Add to that, the constant awareness of the risks involved, the knowledge that one wrong move could spell disaster, and the ever-present communication delay that makes real-time conversations with loved ones back home impossible. The human mind, for all its adaptability, is not well suited for such prolonged isolation and confinement. The lack of privacy, the monotony of routine, the absence of familiar sensory stimuli, and the constant stress can take a toll, leading to anxiety, depression, sleep disturbances, interpersonal conflicts, and even cognitive decline. Maintaining psychological well-being during a multi-year Mars mission is crucial, not just for the astronauts' mental health, but for the success of the mission itself. A psychologically distressed crew is more prone to errors in judgment, communication breakdowns, and interpersonal conflicts, all of which could jeopardize the mission. Addressing these challenges will require a multifaceted approach, encompassing careful crew selection, pre-mission psychological training, in-flight psychological support, and the creation of a spacecraft environment that fosters a sense of community, purpose, and connection to home. The price of ambition. The financial burden of Mars. Reaching for the stars has always come with a hefty price tag. But when it comes to Mars, the cost of ambition reaches astronomical heights, pushing the limits of even the most well-funded space programs. Sending humans to the Red Planet and bringing them back safely requires a staggering investment, one that dwarfs the cost of even the most ambitious projects undertaken by humanity. Imagine the cost of developing a spacecraft capable of carrying humans safely to Mars and back. A journey of millions of miles through the hazards of deep space. Consider the resources needed to develop the life support systems, the radiation shielding, the communication systems, and all the other technologies essential for human survival in such a hostile environment. Factor in the cost of launching all of this hardware into space, overcoming Earth's gravitational pull with powerful rockets that consume vast amounts of fuel. And that's just the tip of the financial iceberg. Once on Mars, astronauts would need a habitat to protect them from the harsh Martian environment, a source of food, water, and oxygen, and the means to explore their surroundings and conduct scientific experiments. Establishing a sustainable human presence on Mars, even for a short period, would require a continuous stream of supplies and support from Earth, adding further logistical and financial complexities. The estimated cost of a human mission to Mars varies depending on the mission's complexity, duration, and scope. Some estimates place the price tag in the hundreds of billions of dollars, while others suggest it could reach trillions. These figures, while staggering, represent not just the cost of sending humans to another planet, but also the investment in the technologies, the scientific discoveries, and the inspiration that such an endeavor could generate. A unified front, the need for global collaboration. The challenges of reaching Mars are immense, complex, and costly. No single nation can shoulder the burden alone. A human mission to Mars demands unprecedented international cooperation. Imagine scientists and engineers from around the world pooling their knowledge and resources. Picture space agencies sharing the cost and risk of developing the spacecraft and infrastructure. Envision a global network of ground stations, tracking the mission's progress and relaying data. International collaboration in space is not new. The International Space Station is a testament to human cooperation. A Mars mission requires even greater commitment and coordination, extending beyond national interests. The benefits would foster innovation, education, and a renewed sense of global unity. Humanity has the opportunity to come together, united in our quest to explore the cosmos. The red planet beckons, a test of our limits. The path to Mars is not paved with convenience. It is an arduous, demanding journey, fraught with challenges that test the very limits of our technological prowess and human resilience. The vast gulf of space, the unforgiving nature of the Martian environment, and the profound effects of long-duration spaceflight on the human body and mind. These are not obstacles for the faint of heart. They are challenges that demand innovation, collaboration, and an unwavering commitment to pushing the boundaries of what's possible. We must develop spacecraft capable of withstanding the rigors of interplanetary travel, shielding their precious human cargo from the relentless onslaught of radiation. We must devise ingenious ways to land on a planet with a thin atmosphere, a feat that has bedeviled even our most sophisticated robotic explorers. We must find ways to sustain human life for years on a world where resources are scarce and the environment is hostile. And perhaps most importantly, we must prepare the human spirit for a journey unlike any undertaken before. The isolation, the confinement, the constant awareness of the risks involved. These psychological challenges are as daunting as the technical hurdles. We must equip our astronauts not only with the skills and knowledge to survive, but also with the mental fortitude to thrive in the face of adversity, millions of miles from home. The journey to Mars will not be easy, but the rewards promise to be immeasurable. It is a journey of exploration, of discovery, of pushing the boundaries of human knowledge and capability. It is a journey that will test our limits, challenge our assumptions, and ultimately reveal the true potential of the human spirit. A Martian legacy for ourselves and future generations. Why do we strive then to reach this distant, unforgiving world? Why pour our resources, our ingenuity, our very hopes and dreams into a venture so fraught with risk? Because Mars is more than just a destination. It is a symbol, a challenge, a mirror reflecting our own potential as a species. It is a testament to our insatiable curiosity, our relentless pursuit of knowledge, our innate desire to explore the unknown. The pursuit of Mars is not merely about planting a flag on another world, though that is certainly a symbolic achievement. It is about unraveling the mysteries of our solar system, searching for clues about the origins of life, understanding the forces that shaped our own planet, and perhaps even finding evidence of past or present life beyond Earth. It is about developing technologies that will benefit us here on Earth, from advancements in propulsion systems to innovations in sustainable living solutions. It is about inspiring future generations to pursue careers in science, technology, engineering, and mathematics, to dream big, and to push the boundaries of human achievement. The journey to Mars is a legacy project, an investment in our collective future. It is a testament to the enduring human spirit, our capacity for innovation, and our unwavering belief in the power of exploration to transform our understanding of ourselves and our place in the cosmos. It is a journey that we embark on not just for ourselves, but for all humankind, for the generations yet to come who will inherit the knowledge, the inspiration, and the future that we dare to imagine. Watch this video to see how long it would take to reach every planet,